Hi, this is Graham Bell with EDA Cafe and IB Systems. I have the pleasure of speaking with Raul Campesano from Nimbic. Hi, Raul.
How are you? Very good to see you.
It's Wednesday morning here at DAC 2011 in San Diego. I understand there's been some important developments at your company. Previously, you were known as Physware.
Correct. We just changed our name as a response to a few things, right? One is, of course, the cloud. Nimbic is derived from Nimbus, the cloud. I see the integrated circuit and also being nimble. So this is a name that is much more in line with what we're doing now. The second thing is that we just released our nCloud product, which is the first version of our products in the cloud, and we also closed a new round of funding, so in a sense we are a new company.
Tell me about the round. Is it a B round?
It's a B round, 6.9 million, right? Our main investor is Madrona, which is a company out of Seattle, right? They are one of the early investors in Amazon, I understand, as well, right? And so we're very aligned with them regarding the cloud.
Well, congratulations. It's good news to see investment in our industry. Can you tell us a little bit about nCloud and what kind of design problems it solves?
Yeah, so nCloud is the name of our cloud solution. So by itself, it doesn't do anything, right? It hosts products on the cloud. So we have 4 products, of which 2 are now on the cloud. One is nWave, which is our 3-dimensional wave solver, full wave solver. And the other one is an Apex, right, which is a quasi-static version of that. So these 2 products are hosted in nCloud on the cloud, and the way it works from a user point of view is that essentially you have the GUI on your computer, but the solver, right, the heavy lifting that requires all the computers happens in the cloud in an almost transparent way.
Very good. And I assume there's some way in the cockpit to decide how much of resources I will use on the cloud, whether 10 servers or 1,000 servers.
Yeah, correct, right? So the input you need to do this is an IP address, which you get from us, right, that is sort of to your portal in the cloud, your private portal, right? So these are virtual machines, but they are dedicated exclusively to the user, to you. Of course, the second thing you need is a key, right, which is a key pair, really, right, private-public key, right? Everything is encrypted, both at rest and in transit, right? And the third thing you need, right, is a certain number of nodes, we call them compute nodes, which is what you're referring to. So if you type in 10, right, then you'll have 10 computers, and all the jobs that you send will be queued in 10 computers, right? Our software is highly parallel, right? So it can run literally on hundreds of computers, right? And so you can get your results very, very quickly, right? And from a user point of view, really the model is very attractive, because using 100 computers for 1 hour costs the same than using 1 computer for 100 hours. And so if your software parallelizes well, right, then of course you'd rather pay for 100 computers for 1 hour.
That's a very attractive business model. Can you talk a little bit about the design problems that your software solutions address?
Yeah, so we have electromagnetic solvers, right, 3D electromagnetic solvers, and they are typically used chip out today, right? So what we do is we solve Maxwell's equations for a typical connection that goes from the pad on the actual die, right, on the chip, through the bonding wire, right, through the pin, maybe through a solder ball, to a via, and to some connection on a board, right? And so that's a 3-dimensional structure, as you could easily see, and to model that accurately electromagnetically, you have to really solve Maxwell's equations. And the output of that is either EMI, right, the actual electromagnetic fields, near field or far field, depending on whether you're doing an antenna, then you're interested in the thing radiating. If you're doing a chip, you don't want it to radiate. And then Z parameters, right, which are S parameters, Y and Z parameters, right, but typically S parameters, which are used for SPICE then to calculate signal integrity and power integrity. So those are the 3 main applications: EMI, signal integrity, and power integrity for what we call systems, which is package board.
Can you talk a little bit about the ecosystem with Nimbic, perhaps some partner relationships that you have?
Yeah, we partner with companies that actually allow people to do the board design, right? So the main ones there, of course, being Zuken and Cadence, right? We also partner with Dassault regarding the software to do 2- and 3-dimensional meshing and to draw 3-dimensional objects, right? And so those are the kind of partnerships we have. And then we connect, we also partner with Synopsys, right, regarding HSpice, right, and Cadence also regarding their simulator, right? And that is a typical connection that you have, right, in our ecosystem. You have to design the package, the board, right, which is a geometrical thing, and then the output of us, right, often goes into an electrical simulator like HSpice.
Raul, how can our audience who are watching from home find out more about Nimbic?
www.nimbic.com.
Raul, thanks for speaking with our EDA Cafe audience and bringing us up to date.
It was a pleasure. Thank you so much.